All right, so we've got this pretty hefty stack of research papers
Yeah.
all about reasoning models,
Mm-hmm.
AI learning to reason. It sounds kind of like something straight out of science fiction.
It does, doesn't it?
But from what I'm seeing here, it's becoming very, very real.
It is indeed. And what's fascinating is how much our understanding of reasoning models has changed. For the longest time, researchers thought you absolutely needed symbolic components,
Okay.
those rule-based systems,
Uh-huh.
for AI to crack those really complex reasoning problems.
So like kind of how we teach logic and math.
Yeah.
With like very specific rules and formulas.
Exactly. But some of these papers are really challenging that assumption. Like one study highlights this really cool new framework called test time training, TTT for short.
Yeah.
Basically, it shows how neural networks, those flexible learning-based systems,
Right.
can tackle tasks that were previously thought to be like the sole domain of program synthesis.
Okay, I'm all ears. How does TTT work?
Think of it this way. The model gets a little warm-up
Uh-huh.
for each problem it encounters. With TTT, it basically fine-tunes itself on a mini data set
Okay.
created specifically from that problem.
That's just
Almost like practicing on similar questions before a big test.
right.
Then it resets back to its default state for the next challenge.
So it's like the model is doing some targeted cramming before each exam.
Exactly.
But what kind of problems are we talking about here?
Well, this study looked at problems that traditionally require like breaking things down into those logical steps
Okay.
and applying rules,
Right.
things like solving mathematical equations or writing code or even figuring out how to navigate a maze.
Got it. So tasks that might seem pretty straightforward for us humans,
Yeah,
but require a very specific kind of thinking process for an AI.
precisely. And what's remarkable is that the success of TTT suggests it's not so much about the type of system,
Okay.
like symbolic versus neural,
Hmm.
but more about how the model uses its computational resources.
Yeah.
At the moment, it needs to solve the problem.
That's a pretty big shift in thinking.
It is.
It sounds like it could have some interesting implications for how we design AI systems for learning.
Yeah,
Maybe even how we think about teaching in general.
it certainly does. And speaking of how models learn to reason, another study used a technique called influence functions
Okay.
to essentially track which parts of a model's training data are the most impactful for its reasoning abilities.
Okay. Intriguing.
Mm.
What did they find? What kind of clues stood out?
They discovered that for reasoning tasks, the most influential data often involves what's known as procedural knowledge.
Procedural knowledge. Refresh my memory. What does that mean again?
It's essentially knowing how to do something,
Right.
as opposed to just knowing facts.
Okay.
Think about following a recipe or solving a math problem or even learning a new language.
Right.
It's not just about the ingredients or the vocabulary.
Oh, yeah.
It's understanding the steps and processes involved.
Right. It's the how-to knowledge. So are they saying that models are actually learning these procedures from the data?
Exactly. And this is where it gets really interesting.
Mm-hmm.
A significant amount of this influential procedural knowledge is coming from,
Okay.
wait for it, code.
Wait, seriously? They're learning to reason from computer code.
Yes.
That's wild. How does that even work?
It seems that by being exposed to code during training, models develop a stronger grasp of logical steps and sequences,
Okay.
which is crucial for reasoning. Code is all about clear instructions,
Right.
logical flow, and breaking down complex tasks into smaller, more manageable steps.
So it's almost like code is acting as a kind of blueprint for logical thinking.
That's a great way to put it. And this has some pretty interesting implications for how we think about teaching and learning. What if we incorporated more of that procedural problem-solving approach,
Yeah.
inspired by the way code is structured?
That's a fascinating thought.
Yeah.
If AI is picking up these skills from code, maybe there's something there for us humans to learn as well.
Yeah.
But beyond just logical thinking, what about problems that don't have a single right answer?
Right.
The kind of challenges we face in the real world where creativity and flexibility are key.
You're right. That's a whole other dimension of reasoning.
Yeah.
And thankfully, the research is exploring that too.
Yep.
One paper we have focuses on a new model called Marco O1, which is designed to tackle these more open-ended problems.
Sounds promising. Tell me more.
Well, Marco 1 uses a combination of techniques,
Okay.
one of which is called chain of thought prompting.
Okay.
Essentially, you guide the model through a series of thought steps, almost like having it think aloud.
Okay.
This helps it break down complex problems into smaller, more manageable parts.
So instead of just giving a single answer, Marco Owen is encouraged to walk through its reasoning process.
Yeah.
almost like how we would solve a problem.
Exactly. And on top of that, it uses a technique called Monte Carlo tree search, which essentially explores multiple possible solution paths. Imagine a tree with branches representing different choices and outcomes.
Yeah.
This approach allows Marco Lewen to consider various options and figure out the best way forward, even when there's no single right answer.
So it's exploring different paths, considering different possibilities, and learning from its mistakes. That's pretty impressive.
It is. And this has huge implications for real-world scenarios, where problems are often ambiguous and solutions require a mix of logic, creativity, and adaptability. Think of things like writing a persuasive essay or designing a marketing campaign.
Oh, yeah.
Or even navigating complex social situations.
It sounds like this type of model could be a game changer, not just for solving specific problems, but for helping people develop those broader critical thinking skills.
Absolutely. And that's just scratching the surface of what these models can do.
Wow, this is all so fascinating.
Yeah.
I'm eager to hear more about what else these researchers are uncovering. Where do we go from here?
So we were just discussing how Marco O1 can explore those multiple solution paths using that Monte Carlo tree search method.
Right.
And that kind of reminds me of another intriguing finding from these papers.
Oh, yeah. Tell me more. What caught your eye?
Well, one of the studies discovered that when it comes to reasoning tasks, the influence of individual data points is a bit different than for, like, factual questions.
Okay.
Remember how we talked about those influence functions acting like detectives, figuring out which parts of the training data matter most?
Yeah, the superstar data versus the background players.
Exactly. So for factual tasks, it seems like those superstar documents packed with those really specific facts,
Right.
they make a big difference.
Uh-huh.
But for reasoning, it's less about those individual standouts and more about a broader range of influences.
Interesting. So it's not just relying on like one key piece of information, but kind of pulling from a wider tapestry of knowledge.
Precisely. It suggests that reasoning might be more about synthesizing information from a bunch of different sources rather than memorizing specific facts or examples.
Makes sense. Reasoning requires you to connect the dots,
Yeah.
see the bigger picture, not just recall isolated bits of information.
Exactly. And this finding has some pretty significant implications for how we think about teaching and learning. If we want to cultivate those strong reasoning skills, maybe we should be focusing less on rote memorization
Yeah.
and more on helping students develop those critical thinking muscles.
Absolutely. It's about empowering students to analyze information, evaluate different perspectives, and form their own conclusions,
Yeah.
not just regurgitating facts.
Precisely. And this brings us to another really fascinating aspect of these reasoning models.
Okay.
They can sometimes come up with solutions that are completely out of the box.
Oh,
Things even the researchers didn't anticipate.
you mean they can be creative?
In a way, yes.
Yeah.
Think back to Marco 1 and that Monte Carlo tree search method. By exploring all those different solution paths, it can sometimes stumble upon approaches that are truly novel and unexpected.
Wow, so they're not just following a predetermined script. They're capable of generating genuinely new ideas. That's incredible.
It really is, and this potential for creativity has huge implications for all sorts of fields, from scientific discovery to artistic creation. Imagine a world where AI can help us come up with new inventions, write groundbreaking screenplays, or even compose symphonies.
The possibilities are mind-boggling. But hold on a second. If AI can learn to reason so effectively, what does that tell us about the nature of human reasoning? Are we just complex algorithms ourselves?
That's the million-dollar question. By studying how AI models learn to reason, we might actually gain a deeper understanding of our own cognitive processes. It's like holding a mirror up to ourselves, only the mirror is made of algorithms and data.
I like that analogy. It's like we're getting a glimpse into the inner workings of our own minds through the lens of AI.
Exactly. And just as we're always learning and evolving, these reasoning models are constantly being refined and improved. Who knows what amazing discoveries we'll uncover next?
It's an exciting time to be following this field, that's for sure. It
Yeah.
feels like we're on the cusp of something truly revolutionary. But we've been so focused on code and these abstract models. I'm curious, what about the role of other types of data? Does that factor into a model's reasoning abilities? We've been talking a lot about code as like a training ground for these reasoning models. But what about other types of data? Do those play a role too?
That's a great question. And one of the papers actually tackled this head on. Researchers wanted to see which data sources had the biggest impact on different reasoning tasks. They used those influence functions, again,
Correct.
kind of like a detective's toolkit to pinpoint the most influential data.
So did they find any surprises?
They did. For questions focused on facts, Things like Wikipedia and trivia really stood out. Makes sense, right? Those are like classic sources for straightforward information. But for reasoning tasks, the heavy hitters were a bit different. Math Stack Exchange, scientific papers, and yes, you guessed it, code once again.
It's like a recipe for a master reasoner, a blend of structured knowledge, problem-solving techniques, and those clear logical instructions from code.
Exactly. And this reinforces the idea that procedural knowledge is really key for reasoning. It's not just about knowing the what, but the how.
And it seems like code provides a really rich source of that how-to knowledge, almost like a blueprint for logical thinking.
Right. But here's another interesting twist. The influence of code wasn't limited to just the top-ranked, most influential documents.
Okay.
It even extended to those ranked lower, suggesting that code might have a more subtle, pervasive impact on a model's reasoning abilities than we initially thought.
So code is almost like a secret ingredient that seasons the whole data set, enhancing the flavor of the reasoning process, even if it's not the main course.
I love that analogy. It highlights how important it is to carefully consider what we're feeding these models. If we want them to be powerful reasoners, we need to provide a diverse and information-rich diet. It makes you think about how we approach learning in general, doesn't it?
It really does, especially when you consider how these reasoning models are constantly being refined and improved. Who knows what amazing discoveries are just around the corner?
Exactly. And not just for AI. By studying how these models learn to reason, we might gain a deeper understanding of human cognition and the very nature of intelligence itself.
It's like we're unlocking the secrets of the mind, one algorithm at a time.
Indeed. And the insights we're gaining have profound implications for everything from how we educate to how we work, maybe even, to how we understand our place in the universe.
Wow, it's incredible to think about the ripple effects of this research. And I have a feeling we've only just scratched the surface.
I couldn't agree more. The journey of discovery has just begun, and it's an exciting time to be along for the ride.
That's a great note to end on. We've covered so much ground today, from test time training and the surprising influence of code to the challenges of open-ended problem solving. It's clear that reasoning models are pushing the boundaries of AI and giving us a whole new perspective on how we learn and think.
Absolutely. And as these models continue to evolve, who knows what we'll uncover next?
A big thank you to our expert for guiding us through this fascinating world of reasoning models, and to you, our listener, for taking this deep dive with us. We hope this has sparked your curiosity and given you plenty to ponder. Until next time, keep those minds sharp and stay curious.